Okay, all right, so my name's Laura. That's a slide about me. It makes me deeply uncomfortable. In fact, this isn't about me. It's about you. How many of you have done crime? So committed a crime in your life? Raise your hand. Oh, come now. I've watched the roads here, seriously. Okay, today we're going to talk about security, and more importantly, we're going to talk about your job when it comes to security. Now, I saw you raise your hands earlier. We had full stack developers, back-end developers, front-end developers, upside-down developers, one of everything in this room. But the funny thing is, how many of you raise your hand as a security person? Anyone security? Raise your hand. Are you a security person for your organization? Well, congratulations. You can all go and update your LinkedIn as of today. As of today, I crown you security people. Congratulations. You get no extra pay. You're guaranteed to have trouble most weeks, and you'll have more work than you've ever had in your life. Sounds fun, right? In today's talk, we're going to cover a few things. We're going to talk about fear and why security matters. We're going to talk about architecture as it was, so how we used to think about securing our systems and, to an extent, our buildings and our people. We're going to talk about some of the scar tissue and the anti-patterns there, and then we're going to move on to talk about how we think about security in our new architectures. Now, raise your hand if you work for a startup or a young company. Yeah, you can tell you do, because you've got training budgets. You're allowed out of the office to do things. Everyone else has to kind of figure it out for themselves. Now, you're in a beautiful position. You're probably creating greenfields, new applications. How many of you are working on a legacy system? Raise your hand, legacy folk. Right, good. You've got a different set of challenges. Now, startup people, find a legacy person and apologize to them. The startup people of today are the legacies of tomorrow. So remember, the choices you make today will punish someone else tomorrow. So how does fear work? Why do we care about security at all? Well, the reality of the world is that there is always something bad going to get us, right? Now, we're used to historically being a monster, as something physical was going to eat us or attack us in some way. Now, as things have moved on, we now have different threats. Rather than it being something we could touch or see or smell, it's something that is online. It's ephemeral. It's something that we can't conceptualize or see or touch. And that makes it very difficult to defend ourselves. If I told you a bear was walking onto the stage right now and was really hungry, you'd all know roughly what to do. About 5% of you would run this way. About 80% of you would surge the doors. At least 2 of you would try and take a selfie. You understand that a bear would like to eat you. You're tasty to bears. But when I tell you that the systems you're building are under attack by some form of threat actor, we just kind of go, what does that mean? You can't hit them with a stick. Running for the exit isn't going to help. And the reality is there are lots and lots and lots of things that could go wrong, lots of security issues. Now, the ones we think about and talk about a lot are things like state actors, the governments of the world are going to hack us. Then there's the organized crime gangs. But the reality is there's a whole range of ways it could go wrong. And to be honest, the number one cause of security incidents is in this room today. It's you. Again, something else for your LinkedIn. The inside threat, the people in your organization, are going to cause the most security risk of any other group involved in your system in its whole life. And so we need to think about this. When we're thinking about security architecture, it's not just protecting against the unknown threats from the wider world, but also the threats that are inside our organizations. The threats are there because people could be malicious or because they're having a bad day. Raise your hand if you've ever had a bad day at work. Yeah? I call that Tuesday. How many of you have had a day where you're tired and have made mistakes? Yeah? Security issues come from these places, not just the malicious actors in the world. But regardless of where they come from, they result in the same thing. We either have the urge to fight it, so we lash out, let's attack them back. By the way, if the bear thing happened, don't do that. You versus bear isn't going to win. You might have flight, you might run away from the prospective attacker. So let's not build that crazy future system, because then we won't have to deal with the attackers. But most of us are stuck in this third phase of freeze. Bad things happening, we know it's bad, and we have no idea what to do about it. So hopefully today we're going to move past that. These are the three things we're trying to protect. The confidentiality of our data, the integrity of the data, making sure it's in the state we expect it to be in, and its availability. Now, when I first started in security many years ago, I was 16, and the system I was working on, I was a COBOL developer, because I'm cool. I was working on taxation systems, so available for us meant 9 o'clock in the morning till 5 p.m., Monday to Friday, and that was it. 15 years later, we expect our systems to not just be available 24/7, but we expect them to be highly available, to be fast and performant, not just secure. And that's quite a big balance for us to meet in our architectures. When we're planning our controls, we're balancing three types of controls. So you're not just planning how to stop bad things happening, which is prevention. We're trying to detect them. So how do we know that the bear has gotten into the building? How do we know that somebody is trying to steal from our online bank, or is trying to order too many pairs of shoes they haven't paid for? How do we respond to that is our third. So it's all very well spotting the bad thing is happening, but what are we going to do about it? And architecture encompasses all three of these. It's not just the system we build, but it's the processes and responses we have around it once it's operational. So how does this work, and how did we come to this place with online security? Let's talk about the old school ways. So this is a castle. Now, I'm very bad at art, but it's a very pretty castle. Our white is our external wall. So historically, when we built something, whether it was out of stone or whether it was digital, we are used to the outside border being our biggest defense. So historically, we would trust anything inside that border, as you had to be an employee to access it, or you were supposed to be there. And that's pretty much where security architecture came from. If you look at the old textbooks for it, all of the focus was on things like have a firewall, maybe lock the front door. It was about prevention, and it was prevention at the border. If you manage to make it to the little square in the middle, you're great. You've got access to pretty much everything because you are trusted. You are there and you are trusted. Now, at the beginning, I asked you who'd done crime. Raise your hand again. Oh, you don't want to answer it now, do you? Well, all of you folks and me, all of us, we tell lies, we cheat, we steal. It's actually part of being human. The degree at which we do it is what separates us from true criminals and going to prison. Now, if we trust everyone in our organization so everyone can touch our precious data, say in the middle, then we have this problem, because that outside border is not going to protect us if our threat is already through the front door. Naive security architecture, or historical security architecture, focused just on this external wall, under the belief that that's how we built our castles, our big defensive structures. All the castle had, right, was a big wall. You couldn't get through the wall. Great. I believe there's some American dude who thinks a wall is going to save him in the same way. Layered defenses create an expectation of safety. It's kind of like saying, well, I'm here now, I'm inside, I'm safe. But in reality, it takes a lot more than that. Now, let's think about castles particularly. If most of our controls are focused on prevent, then what on earth are all these? So these are examples of actual defences from actual castles around the world, so physical buildings, old buildings from hundreds of years ago. They would be built in ways that had dozens and dozens of security controls. Everything from tall walls to turrets, to the fact that if you went into the stairs in one of the turrets, the stairs would circle in a way that favoured the sword hand of the defending army. So if you went to the top of the stairs and you were defending your castle from the invaders below, your hand would be free to swing a sword, and the people who were attacking upwards would hit their hand on the wall. Now, that was favouring right-handed swordspeople in almost all the world, except for Scotland, because in Scotland, they primarily have left-handed swordspeople, so they built their staircases in the opposite direction. We have everything from gates and archers to the ability to throw hot oil on people. We had lots. But only a few of these were really preventions. Only a few of these stopped things from happening. The others were detective and responsive. So if we look at it in a different way, here's our list again. So our white controls there are defenses, so preventions, much like our wall. Stop the bad thing happening. Our next group, the blue options on our list, are our detective controls. So ways to spot that bad things are happening. Our purple ones then are our response. So even if our prevention fails and we spot a bad thing's happened, we knew what to do. We could use an escape tunnel. We could fire arrows. We could throw oil. So as you can start seeing, this idea that we built our software systems to just be one big border and everything inside is trusted because it's inside our organization isn't learning from the lessons of the past. In fact, our systems need as many controls as an old school castle would. And I'm going to show you what that might look like. If we look at them in their lists, you see that actually it's not like we favor one at all. It's about a third split, give or take, if you don't assume they are all equally complex to implement. Our controls in our architecture have to bear things in mind. They have to prevent what we can, detect what is happening that we didn't foresee, and respond quickly. And most of all, we have to assume we are compromised, which means going and looking at our architecture and saying, the bad threat is already here. The bad thing is already happening. What can we do? And that is quite a different mindset. It actually makes you feel a little vulnerable to say, hey, no, the attacker is here. We need to do this now. Because, well, we like to believe we build secure systems, that we built tall walls and the bad people can't get in. Saying we screwed up and our baby is ugly and the attacker is already sat at the table is a kind of admitting defeat, right? Feels weird. But as architects, feel that vulnerability and embrace it, because that's your chance to plan controls that work. Our defenses can be built into all of our architecture, plus into our deployment, into our integrations with third parties, into the deconstruction of our services away from monolithic architectures into either ephemeral or Lambda-based architectures or microservices. How many of you have gone microservice now? How many of you are still feeding and watering a monolith? It's all right. Raise your hand, monolith people. Be proud. The world is built on monoliths. Don't let Sam Newman tell you otherwise. It's okay to build your defenses in each part of this and pick the ones that suit your particular space, your architecture as it is right now, not the dream architecture that Netflix happened to be building in California. On a side note here, let me just talk about scar tissue. How many of you have seen a warning label like this before on a packet of nuts? Yeah, so may contain nuts on a packet of nuts. This is what we call a scar tissue control. So when you are planning the controls in your architecture to defend, watch out for this. These tell a story. They tell the story of things that have gone wrong for security for you before. They didn't choose to put a nuts warning on a pack of peanuts because they thought it was a great idea. They put it on there because somebody ate some peanuts and went, oh my goodness, there's nuts in here. And they were surprised by this. And so a lawyer came along. And then we had warnings. This is scar tissue. This is scar tissue. Choosing passwords and you get error messages like this. Any of you seen this kind of thing? Yeah, if your password doesn't look like this thing or it isn't the right phase of the moon, you cannot continue. If you are planning the security controls for your architecture, keep an eye out for nausea. So there we go, as an acronym for you today. So controls that are not measurable, that are acute, so very specific, are useless. Specific, exclusionary, and arbitrary. Every security control we have has to have a purpose, and we're going to talk about that with those lists of preventative, detective, and responsive controls. Scar tissue makes us feel like we've done something. We have some security in place because, look, we have some rules, we have a policy. You have to be able to measure the effectiveness of your controls. What are they actually protecting? So how do we do this? Let's spend the last 8 minutes figuring that out. It's not long, but believe me, if you've ever committed a crime or told a lie, which I believe, to be honest, you look like the group that has, I've met some of you, you're lovely, but charming thieves. Right. So, we're going to go from our big wall to our more modern architectures. This is what our architectures look like now, right? Lots and lots of dots, lots and lots of lines, lots and lots of Microsoft Visio licenses languishing on computers. We need to choose the controls for each section of our architecture specifically to protect against different threats. For example, externally facing applications might just be front-end code. It might just be React. It might just be Angular. Those have a very different logical model than our back-end code, which might be here, might be our API layer. We've got to choose the right controls for each. There's no point in building too much into the wrong place. If this is our core data set, we have to treat it like it is the most precious thing in the world to us, because for most of our companies it is. That is our crown jewels. We're going to split our controls between the three, roughly thirds, preventative, detective, and responsive. And here are the kinds of controls we're talking about. Talking about not trusting input, no matter where it came from. It could come from another system you wrote. But like I said earlier, we have bad days. Code doesn't always meet the grade. We don't always write the right solution first time. So we have to treat the other components in our system as untrusted. It could be in some form of encapsulation or serialization where we're taking data and wrapping it to protect it. Protect it from us and us from it. We need automation testing. I was quite sad we've got no QA folks in the room. They're not in this room. In fact, they're very rarely in these kinds of rooms. Go help them find ways to test your architecture from a security point of view. Look for the principles of least privilege, so take away access where it is not needed. If your end point in your architecture, if we go back to our previous diagram, is only querying and looking up data from one table, only give it that access. When you're planning your controls, the idea is not to find dozens and dozens of expensive tools and toys. That's really not going to help you. It's not going to be spending $1 million on a web application firewall. While they can be useful, your architecture depends on dozens of small controls deployed in situations that make sense for each one. So if we split them again, like we did for our actual castle, so our white ones being our preventative controls, so things like patching and keeping up to date. So just on that note, full stack developers, raise your hand again. How many of you have looked up your dependencies recently and seen how out of date your libraries are? Right, group, raise your hand if you know you're running an out of date library in your production stack right now. There's at least 20 people in this room lying, or they don't know. And I don't know which one is scarier. Using encryption where appropriate, there is no excuse anymore not to send our traffic over encrypted channels. We should be protecting our data at rest and when it moves, even if that movement is internal within our organization or within our hosting. Because if somebody is inside your environment, that's a weakness too. Our blue controls are our detective controls. So it's all very well to build the fantastic vision of the future for your startup, but if you're not monitoring the logs, if you're not looking for anomalies, you're not going to see them. Now, I don't mean specialist security logs. Any one of you using a database system, you have security logs built in that you wouldn't even realize are there. If somebody is trying to attack your database, for example, using SQL injection, the best place to look isn't a fancy security tool, it's your slow query log. It's the error log on your database, because I can promise you your attacker's making a lot of mistakes when they're on the way to trying to compromise your systems. Use what you have, monitor it, alert from it, and build it into your day-to-day practices. As well as this, go back to that assuming compromise. Write down the scenarios of how this could go wrong for your organization. And then test it. It's kind of like some kind of crazy version of Dungeons and Dragons. I don't know if that made it to Indonesia or not, but I was a nerd back in the day and quite enjoyed my role-play games. Sit down at a table and go, right, what if? What if somebody has managed to get an API key? What if somebody has managed to get onto this server? What could they do? What if somebody lost the password to our deployment server? What would happen? And run through the scenario. What information would you need to say what had happened, and how would you respond? Because by practicing it, you can make it faster and more efficient when you really have to do this. These slides will be available afterwards, but these are the kinds of controls you would expect to see in your architecture. Now, if you need a threat assessment framework to do that, there are many of free open source frameworks available, things like Stride from Microsoft, where you can think about this in a structured way across your entire documented architecture. But if not, then use that bit of criminal in you and think, well, if I was going to attack this, what would I do? All of our controls should be small, frequently deployed, independent of each other, and measurable, monitored, and evaluated. If it doesn't work, throw it out. Don't look after something that isn't working. Let's talk about intelligent defenses instead of scar tissue. Let's not just do things because it's hurt us before. Also, step outside your own bubble. You are engineers. By virtue of being here, that's what you are. But the way you see systems and you interact with them is not the same as your end users, as the other people in your organization. So challenge your assumptions and go and find out how they use your system. Plan your architecture for the behaviors of people who are nothing like you. You are the outlier. Build your defenses that focus on usability. Don't make them complicated like our password scar tissue, where somebody is really struggling to guess how to create a good password. By the way, spoilers, you're all terrible at passwords too. Allow your systems to be monitored and have good response in place. Now here's an example going back to our passwords of what a good one might look like. It's not pretty, but look at it. It's telling us how long it'd take to crack your password. Now, even the non-nerdy amongst us, that's kind of interesting, right? You're told, my password will take 10 seconds to crack, or 26 years. You're probably going to try and get that number higher. You've got good visual cues. You've got the right colors and symbols to keep it simple. Architecture is about humans. It's about planning systems that humans can use safely and securely, not defending against things that have hurt us before. So, as you're going back to your world, as you're planning your security architectures, I want you to think about this. How will I prevent? How will I detect? And how will we respond? And rather than waiting for a security team to help you with this, I want you to take this responsibility yourself. I want you to say, this is mine to protect. This is my architecture, and we together are going to keep it safe. If you have any questions, that's awesome. You can find me on Twitter's lady_nerd. The underscore is important. The other lady nerd doesn't do computers. Or just drop me an email to laura@safestack.io. I am around a little bit, but just reach out. If you have any questions, let me know. Thank you.